today we'll be discussing what absolute values are, and we're going to be started with our parent function. And our parent function is y equals absolute value of x, and this is what it would look like if it were to be graphed. Okay, we'll also be talking about our asymptotes, our domain, our range, and a transform function now. And we're going to get started with our transform function, which is -3 absolute value of x minus 6 plus 7. Okay. And now our -3 indicates whether it flips. What I mean by flips, so when it flips over the x-axis. Okay. So it's pretty much going to be the mirror image of it. And also it indicates whether it gets narrow or wider. Okay. Our x is always going to be there, so we're not going to mess with that. But our -6 won't always be there. Now inside of absolute value, you always have to remember it's the opposite of what you think. So you might think -6 moves to the left, but really it's going to move to the right. So you always have to remember negative right, positive left. Okay, so we're going to move on to our 7. Now this number indicates whether it moves up or down. And now when it's outside the absolute value, it's always going to stay the same. So +7, you guessed it, it's going to move up. Okay, now if it were to be negative, it will move down. And we'll also be talking about our asymptotes, domain, and range. We'll get to that in a second, but we're going to start with our transform function. So we already know that -3 is going to flip over the x-axis, so our vertex point is going to be upside down. Well, the graph is going to be upside down. So we're going to go into the right 6. So 1, 2, 3, 4, 5, 6, somewhere right here, and then up 7. 1, 2, 3, 4, 5, 6, 7. About right there. Okay. Now, since it's -3, it's going to be facing upside down, like I said, and also it's going to get narrow, so it's going to look like that. Just like that, okay? Let's move on to our asymptotes. An asymptote is just a line that your graph gets closer and closer to but never touches. One example would be this. Line keeps getting closer and closer and closer and closer and closer, but never touches. Okay. So, but in this case, we don't have one because we have a vertex point. So we're gonna put none, and then we are gonna move on to our domain. Our domain is just your x's, and our x's for today, since our graph is only on the positive side of the x-axis, our x's has to be x is greater than 0. Okay, so it's going to look like that. And now your range is just your y's. And your y value, also, I forgot to tell you, also, if it's over here, if the graph is also on the side of where the x's are negative, then it will be all real numbers. And all real numbers symbol looks like this. Just like that. Pretty much an R with 2 lines through it, okay? That so you don't get confused. But in just this case, it's on the positive side, so we're going to stick with x is greater than 0. Now our range is our y's, like I said, and you might think our y's are all real numbers because it crosses over both sides, but really it's not. It has to be y is less than or equal to 7 because that's our maximum point. That's our vertex point. Okay, so it's what it's going to look like. Y is less than or equal to 7, okay? The 7 is the highest it can go, but it cannot pass 7, alright? And that's how you would graph one kind of a transform function.